possible intersect a circle at the following number of points: 4, 5, or 6. So here we will make a diagram for each of the 3 cases in order to know whether they're possible or not. Here we have a circle, 4 points. If we want 4 points, we can do the following: 2 points, 2 points, 4 points. You have 1, 2, 3, and 4. Now, this is possible. Now, 5 points. For 5 points, we can do the following. Here we have 2 more, and 1 more. So, there are 1, 2, 3, 4, and 5 points. So 5 is possible too. Finally, for 6 points, I'll make another drawing. 2 points, and 2 more points. 1, 2, 3, 4, 5, and 6 points. So all of them are possible. Choice E is correct. Now, answer the following question. If a triangle intersects a circle, is it possible to get 1, 2, or 3 points? So, we should make a drawing. Here we have a circle. Now, 1 point. It can be something like this. 1 point. So, 1 point is possible. Now, 2 points. It can be something like this. Here we have 2 points. Now, 3 points, you can inscribe a triangle inside a circle. And that's how we get 3 points, 3 intersection points. 1, 2, 3. Therefore, it is possible to get 1, 2, or 3 points. Triangle ABC has sides AB equal to BC equal to 15 and AC equal to 24. What is the area of triangle ABC? So first of all, since sides AB and BC are equal, then ABC is an isosceles triangle, and its height is also median. We know that AC has a length of 24, then this is 12 and this is 12. Now, here we have a right triangle. Let H be the height of the triangle. We will apply the Pythagorean theorem in order to find the value of the height. 15 squared equals 12 squared plus H squared. H squared equals 15 squared minus 12 squared. This is 225 minus 144 equals H squared. 81 equals H squared. Finally, H equals 9. Once we get the height, we can find the value of the area. The area of triangle ABC equals the height times the base over 2. We can cancel this one. Finally, the area of triangle ABC is 9 times 12, 108. Choice D is correct. In the figure below, polygon MNPQR is a regular pentagon. What is the measure of angle QMP? First of all, the sum of all interior angles in any polygon can be calculated by the following formula. Sum equals 180 times n minus 2, where n is the number of sides. A pentagon has 5 sides, then n equals 5. Therefore, the sum of the interior angles of the pentagon is equal to 180 times 5 minus 2. 180 times 3 equals 540. This is the sum of all interior angles of a regular pentagon. A regular pentagon has equal interior angles. This is equal to this one, and this one. Let alpha be the measure of any interior angle. The measure of alpha is the sum of all interior angles over 5, and this is equal to 108. Now, let's focus on isosceles triangle RMQ. Side RQ is equal to side RM. Therefore, the measure of angle Q is equal to the measure of angle M. Let beta. In the diagram below, DE is parallel to BC and the circle with the center O has a diameter of 225. If DE is equal to 270 and the BC is 135, what is the area of triangle EDA? So, first of all, we know that the center of the circle is O and that AC is a diameter. So, O is the central angle with a measure of 180 degrees. Angle B is an inscribed angle. And we know that the measure of an inscribed angle is half the measure of the central angle. Since the central angle is 180 degrees, the inscribed angle, angle B, must be 90 degrees. Now, we know that DE is parallel to BC. DE parallel to BC. Thus, angle C is equal to angle E, and angle B is equal to angle D. Angle D is also 90 degrees. Now, this angle is equal to this angle because they are opposite. You can notice that triangle EDA is similar to triangle ABC because they have the same interior angles. And since they have the same interior angles, their corresponding sides must be proportional. We know that the diameter has a length of 225. We also know that DE is 270 and BC is 135. See that the proportion between the sides of EDA and ABC is 2:1 because 270 is twice 135. Therefore, the length of side EA must be twice the diameter, twice 225. EA is twice 225, 450. Now, we want to find the area of triangle EDA. Triangle EDA is a right triangle. See that 270 is the height, and we need to know the length of the base, DA. We can use the Pythagorean theorem to find the value of the base. Let x be the base, but also we can use it. In the diagram below, MN is parallel to QT and PN is parallel to ST. Also, MN equals NO and QS equals T. If angle QRO is 80, what is the value of the angle OPQ? So, for this problem, we're going to apply all parallel lines properties. Let's start with MN is parallel to QT. Line MN parallel to QT. That means that angle QRO must be the same as angle M. Now, the problem states that QRO is 80 degrees. So, we have 80 here and 80 here. The problem also states that MN equals NO. Therefore, triangle MNO is an isosceles triangle. And angle O must be 80 degrees as well. Since all interior angles of a triangle add up to 180, angle N must be 20 degrees. Now let's focus in line PN and ST. So here we have PN parallel to ST. That means that angle P is the same as angle S. Now we want to find the measure of angle OPQ. Let X be OPQ, X here too. Now, the problem states that QS equals ST. Therefore, angle Q is the same as angle T. This is angle Q. Now, have a look at angle N and angle T. They both are formed by the same intersection of parallel lines. That means that they are equal angles. Since T is 20, Q is 20 as well, and the missing angle of triangle QST must be 140. Since this is a straight line, X plus 140 equals 180. So for X equals 40 degrees. Choice B is correct.